Hello, my name is Sarah Metcalf, and I'm here to present on the results of the association between sugar-sweetened beverage consumption and BMI based off of an analysis of the behavioral risk factor surveillance system. Over the last 3 decades, obesity prevalence in the United States has radically increased. The dramatic changes in the eating habits and diet of our nation since the 1970s is believed to have triggered this increase in body mass index. Sugar-sweetened beverage consumption has been linked to a huge increase over the last years as well, possibly relating it to this BMI increase. Sugar-sweetened beverages and obesity prevalence have been paralleling each other over the years by both more than doubling. In order to further look into this, we wanted to analyze residents of the state of New York to further identify any possible association between sugar-sweetened beverage intake and BMI. We would like to answer the question, does increased sugar-sweetened beverage intake have an impact on BMI status? So our methods for this analysis. We utilized the 2016 Behavioral Risk Factor Surveillance System Public Use Data File. BFRSS is conducted across the United States in collaboration with the Centers for Disease and Control. It's a survey conducted over the phone on health-related topics. It's designed to collect data regarding risky health behaviors, chronic conditions, and utilization of preventative services. BFRSS's purpose is to collect state-specific information on these health-related factors and relate it back to leading causes of death and disability. Sugar-sweetened beverage is elected by state. One of those states is New York, which is our subgroup state where we took New York residents. Our outcome variable is a continuous variable BMI with normal weight, overweight, and obese. Our exposure of interest was sugar-sweetened beverages per week as categorical, and the categories being none, 0 to 1, 1 to 7, and more than 7 drinks per week. Our covariates included binary variable sex for male and female, continuous for age, binary for Hispanic, yes or no. Race was categorical with white, black, or other. Education is categorical as high school graduate or less, some college graduate. And income was categorical at less than $25,000, $25,000 to $49,000, and greater than or equal to $50,000 annually. Physical activity is binary as yes has been physically active in the last 30 days or no has not. History of cardiovascular disease is binary as yes or no. And ever diagnosed with diabetes was binary as yes or no as well. In order to clean this data, we first took BMI and excluded anyone with a BMI of less than 18.5 or greater than 40 in order to eliminate those outliers. And then sugar-sweetened beverages, we combined soda and fruit drinks and then recalculated all to be weekly. Age was recoded to 80 if the individual was greater than 80 years old. History of CVD took 3 variables and combined them into the one variable. Ever told had a heart attack, ever told had heart disease, ever told had stroke. And then ever diagnosed with diabetes was coded using the responses assessing for insulin use. And then all refused, don't know, or was not recorded was recoded to 0 to exclude from our data. We utilized complex survey weights, descriptive statistics, and ran simple and multiple linear regression models and looking at the association of sugar-sweetened beverages and BMI. We did this before and after adjusting for covariates. We then did an assumption check utilizing CPR plot, a residual plot, and a QQ plot. All of this was done utilizing the Status software system, version 15.1. So for our results, in Table 1, this is our demographic and descriptive information results. So half of the respondents ended up being male. The mean age was 48 years. The majority of the ethnicity was white at 72%. More than half of the respondents had an income of greater than or equal to $50,000 annually. 19% of the respondents reported consuming more than 7 sugar-sweetened beverages per week. 21% of those respondents fell in the obese category versus the 18% who fell in the normal BMI group. Those who reported no sugar-sweetened beverage intake, 32% had normal BMI, 33% were overweight, and 30% were obese. Respondents who reported being physically active within the last 30 days, 81% of those respondents had a normal BMI. And then those who reported being told they had cardiovascular disease, 5% had a normal BMI, 9% was overweight, and 11% obese. Those who were ever diagnosed with diabetes, 4% were normal BMI, 10% were overweight, and 18% were obese. So Table 2 shows the results from our simple and multiple linear regressions. For every increase in BMI category for those who reported more than 7 sugar-sweetened beverages per week, there was a 1 to 2% increase with a p-value of 0.02, so there is a small association there. With the no sugar-sweetened beverages per week, there was a decrease from obese to normal BMI, from 32% in normal to 30% in obese, with a p-value of 0.003, so there's no significant association there. For our gender variable, our age variable, and our Hispanic variable, we saw lower BMI in association with those three. And then those who reported no physical activity or being diagnosed with diabetes, there was a prevalence of increase in BMI. So in conclusion, the results from this observational study showed a small statistical significance between BMI and sugar-sweetened beverage intake when individuals consumed more than 7 sugar-sweetened beverages per week. There was a greater statistical significance, though, when compared to covariates like physical activity, diabetes diagnosis, age, race, gender, and college graduate status. More research is needed to help further identify associations with the other confounding factors. The additional research on the specific exposures in relation to BMI would play a large role in identifying obesity risk factors, which is a large public health concern within the United States. So a proposed research intervention could be to introduce sugar-sweetened beverage education and increase access to soda and fruit drink alternatives in New York office buildings. So you could do this by utilizing a randomized controlled trial, utilizing 2 office buildings within the state of New York. In the first office building, you could include soda machines that have water or soda alternatives in them and eliminate the sodas. Types of beverages and snacks provided in the workplace have shown to impact BMI and choices made by employees. Then in building 2, you would utilize the same soda machine elimination and adding water and soda alternatives instead. But in addition, we would hang infographic relating to sugar-sweetened beverages and BMI in and around break rooms and kitchens, educating employees on risk factors related to increased sugar-sweetened beverage intake. Again, previous studies have shown that posters promoting healthy eating in work environments can improve diet choices made by the employees. Ideally, we would want to see 50% of respondents be women and 50% of the subjects be men. We would like to see, again, a variety of races, white, black, other. We would eliminate ever diagnosed with diabetes or ever told they had cardiovascular disease, just to help control the sample population further. And we want to adjust for a level of physical activity as well by assessing the work environment. We want to focus on those who mainly have desk jobs and maybe not those in the office buildings who do a lot more physical activity. This could be a 1-year duration study with lifestyle questionnaires being administered at the beginning of the study and at the end to assess for any lifestyle changes. BMI calculation would be at the initial start, at the middle point of the study, and at the end. We would assess for individual BMI and mean BMI for building 1 and mean BMI for building 2 to better assess any statistical significance there. And we would also want to adjust for subjects lost, individuals who maybe don't work there anymore, dropped out of the study. We would like to adjust for that. And the hypothesis for this would be that building 2 will see more decrease in BMI and sugar sweetened beverage intake than building 1 due to the increase in education provided to this building. Thank you so much.